all, have you slides in your presentation, or should we share the slides? Okay, so just a little bit about organizer. So we organized this skills camp in cooperation with WorldSkills Asia, with COEX, and with our Sakhalin region, which is one of Asian part of Russia, which part of Air-Pacific cooperation, and happy to host this skills camp and have so many countries who is interested to take part. Sakhalin region is quite experienced in WorldSkills development because Sakhalin region have experience to host national competition. And already in Russia, we developed more than 200 competition, and Sakhalin is supported around 89 skills. Next slide, please. And some words about WorldSkills Russia. We are happy that we joined WorldSkills International as a movement. It great for us, gives for us great opportunity to develop our national vocational education system, and now not only vocational education system, all different kind of applied skills is under our umbrella. And we become member for Skills International 2012. We have been experienced to take part in Euroskills and WorldSkills Asia competition. Russia hosts WorldSkills International event in Kazan in 2019. So since that experience, we developed a lot of different new projects. One of the projects was Future Skills, when we develop new skills competition, new standards for new skills and for new jobs, and actually drone operating one of the skills. So we are happy that we are able not just train our competitors, experts, and our students for current job market, but for future job market as well. And Russia is continuing to host international events. We will have Euroskills in 2023 and would like to host competition in 2025. So we really hope that now we are here with you online through COVID, and through now we can really understand that online learning is also very productive and effective. However, we hope that it will be chance for all of you to come to Russia in 2025 for Asian competition. Next slide, please. And just short summary is that we are very happy that you become part of our new learning digital ecosystem. It's great that through this cooperation, we identified that it's really great when we're able to train experts and competitors together, when the students and teachers in the same co-learning system in the same community, because usually we identify that this gives us opportunity to create more holistic picture for all of us. Also, we would like to thank COEX, because COEX developed special digital platform for this training. Also, with our educational partners, we develop and create physical infrastructure of a few testing polygons when it's possible to test drone operating, and it's just possible to make code in one place in one country and pilot this on sites of our institutions. And we're very happy that it's possible to cooperate with other countries and give you this remote access to the platform which have been developed. So we are sure that this camp will be productive. I wish all you good luck and productive day. And thank you again, Svetlana and Oleg, that you arrange this training and give this opportunity. Thank you. That's all from my side.
Thank you, Alina. Thank you for your for this message, for this topic. It's really interesting. It is really great that Sakhalin is a host for WorldSkills Asia cooperation from Russia side. It is amazing. So let's go to the next. And we would like to say many thanks to WorldSkills Asia for supporting us too. And I would like to give a word to President of WorldSkills Asia organization, Chair of the Board, Dr. Mubarak Al-Shamsi. Please, welcome.
Good morning, everyone, and good afternoon and good evening for each time zone difference. My name is Abdullah Al-Marri. I'm from WorldSkills Asia organization. I'm the specialist and financial administration specialist in the WorldSkills Asia. So thank you for everyone who's attending this session, and will be powerful to support everyone there in this session. And thank you for everyone. Thank you so much.
Thank you, Abdullah.
Thank you so much.
Okay, great. So please continue, and let's welcome CEO of CopterExpress, Oleg Panfilenak. He supported us too. Oleg.
Yeah, hello, good morning for everyone. I'm very pleased to be here and to say hello for all of you, and thank you for joining us. As a company, we're very proud to help with this organization, with this camp. And we're also not only help with this camp, we're also very passionate with create and empower all drone communities. Especially for open source drone community, and you can use this knowledge that you will get here today to participate in other events that we organize. For example, some projects, events, hackathons like Copter Hack, and you are very welcome to create your own drone solutions and do something new, maybe open companies, establish startups, and so on. So enjoy this knowledge that you will get, and do something new that will change the world. And we will help you as much as we can. Thank you, Svetlana, and thank you, Alina, and everyone for joining today us, and who make this event happen.
Thank you, Oleg. And now one of the most interesting parts of our camp. So I suggest you to turn on your cameras, and we will create the big common photo, all of our attenders, participants, and organizers. So guys, please turn on your cameras. Great, nice to see you. Oh, great. Many of you we know. Great. I see many of you write in chat hello in different languages, in Russian, in English. Maybe many of you write in the national language. It will be great. Great. So I see many of you turn on the camera, and now I'm going to make a screen, take a screenshot. Just a moment. Okay, so I think you are ready. Where is your smile, guys? Your smile will be on the photo in 3, 2, 1. Just smile. Okay, great. Just a moment. And let's take a smile again. 3, 2, 1, smile. Perfect. And one more photo, please. Are you ready? Where is your smile? Smile, smile. 3, 2, 1, smile. Great. Your good mood gives us energy. Great. Thank you all. So this is our morning routine, and we will repeat this routine all day, all time during our camp. Now I think we are ready to continue. And now I will tell you about the schedule for today. Just a moment, I try to share my screen for you. Where is my presentation? Yeah. Thank you for common photo. And also I would like to introduce with you our organizing team. So this camp will be a great event, and our team is amazing too. So first of all, Timofey Kondratiev, he's a lead trainer of this camp. He will support it and give you more difficult information easily. And also our trainers Nikita Bagatov and Elena Silverstova. These guys will help you during all time, during all camp, and don't hesitate to ask the questions in the common group chat in Telegram. Also, Ilya Khukuni, he is a chief communication interpreter. He is responsible for Asia region development. And you can ask him about cooperation too, as me too. Tatiana Karpova, she is drone operating competence manager for Russia, and she provides aerial robotics educational programs for colleges and universities. And Artur Berendyaev, he is a technical expert on the Sakhalin site. So this is our great team. Yeah, amazing picture was. And some rules for online. So guys, please mute your microphones. It allows us to get a quality conference. And also, please note your name and country in the Zoom account. It will help us to identify you during the camp. So, and of course, we are open for your questions. And if you have a question, you can ask us in the Zoom chat or Telegram group. And we collect one-type questions and answer on it. Don't hesitate it. So I think we have finished with our organizing moments. And now we go to the schedule. So today is the first day, and I would like to tell you about our aerial robotics skill and about WorldSkills Asia competition and camp program, how it will be, about rules and format. Then we will provide mini game. It is our surprise for you. Then we go to the classes. So Timofey will tell you about initial steps in drone programming. After break, we will continue and try it on the real drone on the test type. Then we provide mini game again. It will be surprise number 2. And finally, we provide summary and tell you about homework and some exercises. It will help you to get more experience during our camp. And also you can get a full program via QR code. Okay, go to the next. So some words about aerial robotics skill. You know that drones is most popular vehicles in the world, and now their popularity is grows. So we are CopterExpress company, and we produce drones for educational and for industry. And big drones help us to provide some monitoring and air delivery. Clover drone, it's drones for educational in aerial robotics. Area of application drones is the biggest and is widely, and starting from search and rescue, filming, security, and up to drone swarms, agriculture, surviving, science, and research. So, but now we have one problem. So we don't have enough number of qualified specialists in the autonomous drone hardware and software development area. That is why now in Russia, and we tried to create this system in the world using working with cooperation with WorldSkills Asia and WorldSkills Russia and COEX such as industrial educational partner. We combined schools, colleges, universities, and industry, and it allows us to provide step-by-step education starting from schools and goes to the industry. All tasks can be performed starting from the simple and up to research level task. It allows us to prepare students, teachers, and trainers who want to start in the aerial robotics area. One of the important part in the education is of course drone competitions. So it can be provided offline or online, and we provide different type of drone competitions starting from 12 years old and without upper level. Some words about aerial robotics skill history. So this skill was founded in 2016. In 2019, we provided the first international competition, Worldskills Kazan 2019. In 2020, we provided the first international camp and first international camp with WorldSkills Asia online training. And now we scaled our training. It involves 17 countries. And this will be provided the first WorldSkills Asia online friendly competition for juniors and adult categories. So it's a really great growth. And we hope that it will be successfully experienced for all. So this big growth, to reach this big growth, we use open source platforms for drones, for educational drones and for industrial drones. And it allows us to prepare students on educational drones, such as the Clover, and industrial drones, such as the Pelican. They have one electrical equipment, one brain, Pixhawk and Raspberry Pi, and it allows to get a maximum industrial skills based on the educational equipment. So this educational equipment that we use on our camps, competitions, and in colleges and universities allows us to get different type of skills for students. So starting from assembly goes to the flights, and finally provides autonomous drone programming. And area of application, this skill is really widely. we suggest that one of the most popular and most important skill for future specialists is provide project activity or get knowledge that allows you to create something new or improve existing projects, existing technology, or upgrade it on the new level. So we suggest you to use this educational trajectory to reach out this goal. We're starting from the practice simulation, practice on this Gazebo simulator. Then we provide practice on the real drone, from simulator to real drone. It gets us fundamental knowledge. But one important thing is to provide competitions. Competition allows you to check out your skills and estimate your level. And of course, it's help you to reach out the projects, the creating projects in the future. One of the interesting example I would like to share with you this video. This video was created in the Aerial Robotics laboratory. Students was prepared for the university league, and they created a drone show. It's a really difficult project, but it's really possible when you deep learn aerial robotics. And one of the interesting questions which we have found, some challenges that we have found during the pandemic time, it's how to teach students and how to develop international community during this difficult time. And we have found solution of this problem. We have created a competition management center in the laboratory of universities or schools or colleges who has this infrastructure, and it allows to connect students and attenders from all over the world via internet and working on the real equipment too. So some photos of our competition management centers. And also one of our good practice was in WorldSkills Asia first training. We provided educational with simulator, and this skill was very useful when our students try to participate in the next competitions, and also these knowledges will be great for this event too. So this is example of cooperation simulator with a real drone. So first of all, you perform the task in the simulator, then you check your program on the real site, on the real test site. So this is example of drone monitoring with QR code recognition using computer vision technologies on drone. So attenders has information about from camera view from drone, from the live stream, and some information from the terminal about drone data. This experience gives us a very positive feedback, and we would like to we would like to provide WorldSkills Asia competition. It will be in 3 and 7 August. And this competition will include 2 categories, juniors and adults, and also it will includes 2 tasks, with real Clover drone and task with Gazebo simulator. This method gives us the great skill in the aerial robotics learning process. Before we go to the camp program, if you have any question about theory, it will be great to, you can ask us into Zoom chat. Okay, while you prepare the question, I will continue. Okay, so some words about our camp for today. So why we do it? So one of the most goals for us, it's networking and mutual help and knowledge exchanging. So it allows us to provide popularization aerial robotic skill in the world and combine people who has interest in this area. Also, we have prepared for you the main task. It's a task that give you a real skill that you can use in the future. So this task will be simulated, such as fire monitoring. So during the camp, you will get skill in the base coding of drones, color recognition and computer analysis, and working with the real drone and working with the simulator. We know that it's a difficult task. That is why we divide it on the small task. So, and first of all, step by step, you will learn how to work in Gazebo simulator. Then you will know about differences between simulator and the real drone. In the 3rd day, you will get knowledge about deep learning in color recognition. And in the final day, we provide the main task review and summing up process. So I would like to pay your attention on our schedule. So we will start every day in this time, starting from 16 in the Sakhalin time, or morning in Moscow, starting from 8 a.m. So, and this is our schedule of our days: day 1, day 2, day 3, and day 4. In the finish of each day, we will provide homework. Homework will help you to fix your knowledge that you have got during the 1st day, then the 2nd day, 3rd and 4th days. It's really important for you to do the homework because during this process you will find different problem, and you can ask us in the Zoom, in the Telegram chat, and we will help you to solve it. I see the question in the Zoom chat. So question about, do we learn how to make a drone? So we will give you knowledge about how to drone works, what about the functional nodes of drones, but our camp have a focus on programming drone. Also, of course, you can ask questions during the camp about drone assembly, drone parts, and more. And we will try to ask you in the Telegram group. Okay, so I would like to finalize and finish our first part of today, of organizational today. So we have passed 2 topics. And now time for the mini game. Then we will start our classes and you will get information about drone theory, more about how it works on the real drone. And finally, we create the virtual world in the Gazebo simulator and provide a briefing and homework description for you. So guys, are you ready to start mini game? Please write in Zoom chat plus. Are you ready? Oh yeah, I see. Great, great. So great. So we like your activity. Great. So I think we can start our mini game. Lena, are you ready?
Yeah, I'm ready. Hello, everyone.
I would like to introduce with you Lena. Lena Silverstova. She is a trainer, and she has prepared for you a special game. This game will help you to summarize and help us to summarize your knowledge. Pay attention, be quickly, and Lena, welcome. Please tell us the rules of this game.
Thank you very much. And I share with you my slide. Guys, you hear me?
Yeah.
Great. We have prepared questions for you in the form of a game. We will have such game every day according to the schedule. Have you played Kahoot? If you did it, please, could you please send any reaction to the Zoom? Firstly, you should prepare a phone because you can see question and answer in the laptop screen and can choose answer on your phone screen. I did it. Prepare your phone. Secondly, you should join at kahoot.it. Do it now. And then enter the game pin. You see it and screen. And then enter your name. Yeah, There are so many. I see you are already starting to join. Great.
Guys, we can wait 1 minute and you have opportunity to join for the game.
Okay, great. Now you could see the question on screen, laptop screen, and choose right answer on your phone screen. Let's start. We are ready. Which sensor is used to measure the altitude of the drone? Please choose a right answer. Great. Okay. And next question. Can a quadrocopter fly in a vacuum and on Mars? Yeah. Okay. Next question. What is the brain of quadrocopter? Oh, great. And last question for you. What is responsible for rotation speed on the motors? Almost right. And let's take a look at our podium. Third place, Arno, congratulate. Second place, Mikhailka. And first place, David Dassel, congratulate. Thank you. You did it well, and I give the floor to my colleagues.
Okay, thank you, Lena. Thank you all, guys. So, what do you think about this game? It's do you like it? Did you like it?
Yes.
Of course. Okay, so I think it was a great rest. So are you ready to continue? Yeah, so now we know that I forgot the nicknames of our winners, but other attenders. So guys, I hope you have learned new information. This is new information was useful for you. Okay, so we are ready to continue. Just a moment, I will share my screen. Okay, so now we are ready to go to the classes. And now, Timofey, are you ready?
I'm ready.
Great. So Timofey will tell you about first steps to programming drones. Timofey also will give you information about how to work with Gazebo simulator shortly and how it works on the real drone. So today is the first introduction lesson. Be ready, pay attention, and good luck. Timofey, welcome.
Thank you, Svetlana. I will share my screen now, and we will begin shortly. I also have a presentation. This is more technical. And can you make Svetlana сделай мне? Yes, wait 1 second. I will get the access to sharing my screen. I know a lot of you guys, and I think the same amount of people who I do not know yet. So some of you are already familiar with things I will tell you about today. And for others, it will be the first steps. And I hope you will enjoy it and understand everything I'm going to show you today. All right, so our first step is well, the theory of autonomous drones. What I'm going to tell you about, well, how basically the drone is built, and I mean, what parts it consists of, and what are these parts doing. All right, let's begin with which drones we are going to use. So there's a video that shows what Clover can do. It's an autonomous drone. You can navigate in environment. It can be indoor or outdoor, mostly indoor though. And this drone is used for multiple competitions. One of them is WorldSkills, of course. You can program a swarm of drones, well, mostly a drone show, where you can create animations and control multiple drones at the same time. You can also write any types of programs with drones, and you can put some additional parts, maybe electrical magnet and other sensors. The drones can do some aerial acrobatics, well, aerobatics, like that. It can flip, and but be careful with this. Don't try it in the first day you build the drone. It might become the last day you have it. So anyway, it is equipped with a camera that you can use for computer vision, and we will go briefly with the camera today. Oh, tomorrow, sorry. And you can equip it with multiple different cameras and make cool projects like this is 3D scanning drone. Okay, and this is also an electric magnet. Okay, let's go on. This is our product page where you can find all the tutorials on how to assemble the drone and how to program the drone. If you click this link, we'll share this presentation with you later. This is the assembly of a Clover. Well, there are several different versions of Clover you can choose from. And this is the website that you should remember if you want to work with the drones. It's clover.coex.tech. So what are the parts of the drone? Of course, it's a flight controller, the brain of the drone. Yelena just told you about that. Electronic speed controller, or ESC, is a part that's responsible for controlling the speed of rotation of each motor. The motors, of course, and power distribution board is a board that you connect battery to, and this board will power all the other devices on the drone. The battery itself, the RC transmitter and RC receiver. The receiver is actually put on the drone. Here it's separated, but it should be on the drone. But the most important part for us today is onboard computer. We have Raspberry Pi. It's a very popular onboard computer. It's equipped with a camera for computer vision, a laser rangefinder. This is used for measuring distance between drone and the floor. For the Raspberry Pi itself, it's a small 8 centimeters long computer that we can put on the drone. But the most important for that is the software. Well, Flight Controller is working on a PX4 software. It's an open source firmware for flight controllers. You can find the links here. You can navigate with computer vision. This is an article where you can find more information about marker detection and map-based navigation. So all these links are clickable. Well, on the Raspberry Pi, one of the most important packages is ROS. It's a framework for programming robots. It's a robot operating system. You can also find an article about ROS here. And MAVLink is a protocol for data transfer between flight controller and onboard computer. Also, you have a link for simulator. So this is the link on the documentation. I will show you how to install it properly later, and how to use the simulator. And here you can see a window where there is Aruka markers detected by the drone, and the drone is using Aruka markers for navigating indoors. All right, what's next? So there are several navigation systems available for you. If you have a GPS on the drone, you can fly outdoors with GPS enabled, and you will get coordinates of your flight in global coordinate system. But most of the time, yeah, we will share this presentation with you later. Most of the time you fly with Clover, you fly indoors, so GPS is not available. So you need a system that's working indoor. One of them is motion capture. You can, well, there are big, expensive motion capture systems. They consist of multiple high-res, high FPS cameras. But yeah, it's expensive and big and not so easy to install. But you can find some projects with a web camera used for motion capture. It is cheap, but also requires some work and not so popular yet. I think it will be growing soon. But we are using the vision-based navigation. So this is an Aruka marker field. You can also see our own Aruka marker field. So this is the stream from our camera that I have right in front of me. Those are Aruka markers, and the drone will be flying over them using these markers to get its own coordinate. All right, so what are the first steps in drone programming? Now I will discuss with you about how to install the simulator, which is a virtual machine that contains all the software needed for us. And I will show you how to set it up and start flying the drone with the same Aruka marker field as we have on our real test site. Okay, so what can our simulator do? You can program the drone just the same way that you do with a real drone. I will show you the most interesting parts. So you can debug it right in the console. You can view images from camera, and you can detect like sensor data. You can also use arc markers and arc marker fields and program the drone. And then you can use the same program without changing anything on a real drone. Most of the time it works, but there are some limitations. You can also program LED strip, which is this colorful part of the drone, and it will change colors. The same program will also work on a real drone, of course. And what's here? You can also write a flip, but it will not work on a real drone, so they are not interchangeable. You need to write a separate flip with separate different settings for a real and for the simulator. So this is just a warning for you not to try to use the same program for flip as you used in the simulator. All right, recommended specs are here. It's 8+ gigs of RAM, Intel Core i5, i7, 4th generation and above. It's recommended. Well, it will work if you have lower, but it's recommended. You better have a dedicated graphics card with more than 1 GB of memory and more than 20 gigs of free HDD SSD space. And those are some useful links. We will share these links with you. So you need to make sure you have enabled the virtualization on your PC. So this is the link that you can find some tutorials on how to do that. How to enter BIOS UEFI, and it's usually set in BIOS. Then you need to download VMware Workstation Player. There are also VMware Fusion software for macOS, so you can work with macOS. And VMware Workstation Player is for Linux and Windows. Then you need to download an image here in releases. The latest release is the image that you need to download. This is basically the whole operating system squeezed in one file. You will unpack it and it will work on your computer. And this is the video how you can install all the things and set them up. Okay, let me show you how to do that. I will not do every step by step, but I already have VMware Workstation here. It's downloaded. And I have a virtual machine on the left, but you will not have it for when you first launch it. So let me just install a new one, virtual machine. Open the virtual machine. Select the image with the OVA image that you downloaded. It's about 4 gigs of memory, and open it. Select where you want to install this virtual machine. You can browse and select the one you want. Click import. You can choose a name and edit it. Okay, like that. Click import. Sometimes an error occurs here. If it occurs, just click retry and it will work fine. Okay, what I'm going to show you next is we will be using our Clover COEX Tech website. And here in programming part on the menu, there is a fiducial markers article, and here there is a map-based navigation. So this is basically what you need to set up for enabling Aruku markers to be detected and for configuring your Aruku markers map. Most of the times we are using Aruku markers map, so you can just install the virtual machine, then do every step-by-step what's here, and it will start working from that time. Let me see how it is going. So it's almost installed now. And today I will also show you how to save the world, your virtual environment in simulator, and how to load an external world. I have prepared an external world for you. It's stored in this folder. So you will basically need to use these files and replace the existing files on your virtual machine, as well as models with these files. So this is not difficult. It's pretty easy. You can always watch the video of our session and repeat step by step. Okay, let's see. My virtual machine is installed now, and I need to edit its settings. So before you run it, click Edit Virtual Machine Settings here, and make sure you select the right amount of memory and number of processor cores and some more things. So what about memory? If you have 16 plus gigs of RAM on your computer, go ahead and select 8 gigs for your virtual machine. It's just a half of what you have. If you have 8 gigs on your computer, select 4. It will be enough. Well, but if you have 4, I recommend you changing the computer or using another, because it's too it's just not enough if you have 4 gigs on your computer. So if you just really want to run it, you can select something like 2.5 or something like that. But recommended is 8 gigs. So it's better to have 16 gigs of RAM and use half of what you have for your virtual machine. Then let's go to processors and select the number of cores. Number of cores. How do you know what to choose? Well, choose the half of what you have on your computer. If you open a process manager, you can select performance here, and on the CPU, look how many cores you have. I have 4 cores. Even though there is 8 logic cores, I have 4 physical cores. And I will select 2 cores for my virtual machine. Next, let's go to display. We need to enable the graphics card usage. So check this accelerate 3D graphics and select the memory. Well, you can use 1 gig here, and that should be enough. The next thing is going to options and VMware tools, and check the synchronize guest time with host. Click OK, and you're ready to go. So select your virtual machine and play. It is loading now. All right, my virtual machine is loaded. I can maximize the window to make it bigger. And now we are ready to go deep inside the virtual machine. So Gazebo PX4 is basically the simulator that we are using. Let's see what we got next. So this is the link. Okay, there's a Linux operating system on your virtual machine. So you need to know basic commands, how to navigate in terminal of Linux. So those are the basic commands you will need to work with Clover. CD is for changing directory. Let's see what I'm talking about. So basically, there is a graphical user interface. You can open all the files and folders in graphical interface, but sometimes you need to work in terminal. This is the terminal. So you can write commands here, like ls will return you the list of files and directories in the folder, in the directory where you are currently located. So let's see what we have. ls, list of files and folders. I just showed you. Then change directory is cd. if I want to go to this folder, let me just make it side by side with a graphical user interface. So I'm currently in this home Clover directory, and there is Catkin WS here and here as well. If I go CD and CA tab, enter, I'm in this folder, and I can ls again here, and it will return the list of folders in Catkin WS, just the same as this double click on the folder. All right, what's next? You can remove files with RM, for example. Yeah, let me increase the font size for a minute. Okay, I can create files and remove files. Let me go back to the home folder. It's just CD, enter. I'm back in my home folder. I can create a file with a text editor nano my file.py and print my file. This is a Python program. Control S, Control X, ls. Here's my file. So I've just created a file called myfile.py. And I can run it in Python with the Python command, Python space and my file. I press M, then tab, and it will autocomplete the full name and run. It will run the file. You can see it just printed what was in the print function. And to remove this file, I can write rm myfile.py, enter, ls, and there is no file. I can even make a folder and remove folders, but it will be a little bit different. So to make a folder, I will not use nano. I will use mkdir and the name, like codes, mkdir codes. Okay, ls, let's see. Yeah, there is a codes folder. cd codes, enter. And let's create a file, nano111.py, like that. Control S, Control X. And let's go back. Well, let's see. Yeah, it's here. Go back. You can go back one directory back as just cd space ... and you just back one directory. Or you can go back with cd enter. It will return to the home, which is /home/Clover. All right. There is my folder, codes. Let's try to remove the folder, rm codes. Oh, no, I cannot do that because this is a folder, a directory, and contains files. So you can force remove this folder by rm -rf, but be careful, this will just remove it completely. Codes, enter, and now you can see there's no codes directory. Yeah, you can also rename files with mv. Let's just do that. I think it will be fun to do. For example, if I have a file called, there is a way to create files without opening them, is touch command 123.py ls. Yeah, there is a file. It's empty. Be sure it's empty. And then I can either move it to another directory or rename. It's all the same command, mv. There is no rename command in Linux. There's only mv, because when you move a file, you move it from one name to other name. For example, if I write mv 12 tab, and now I need to type another name like 321.py, enter, ls, and there's 321.py. Or you can move it to another folder like mv32, and now I will type, for example, dot slash Katkin WS 321.py ls. It's gone, but it's now in the folder Katkin WS. Well, dot means current folder, slash is just going next folder, and Katkin WS next file name, and 321.py. cd Katkin ls. Yes, this file is here. In order to remove it, again, I'll write rm321 ls, and there is no file. Okay, this is how you basically work in Linux, in terminal. When working with a real drone, you will only work in terminal. There will be no graphical user interface available for you. This is why you need to know that. Some commands cannot be run without super user permissions, so you need to type sudo before them. Well, maybe I will need that later, and if so, I will show you how to do that. All right. Let's continue with the presentation. If we have a drone and we want to fly in our local area, in our room, for example, we need to know in which coordinate system we are working now. I have a drone here. Let me grab it for you real quick. So this is the drone. Can you see it well? In order for the drone to move in space, yeah, so in order for you to move in space, you need to know from which coordinate to which coordinate you're going to fly. The easiest way for you is the body of the drone. Like the body of the drone is where it is located. So there's a frame of reference called body, well, which is coordinate system. That has 0 coordinate whenever the drone is at the moment. And if you want to fly, for example, 1 meter forward, you just need to use a navigate service in the frame ID body with X of 1, Y 0, and Z 0. And the drone will move forward. But let's go back to the presentation. I will show you with So this is a small drone. I hope you can see it well. And body is the point where the drone is currently. Aruka map is another frame of reference. It is located somewhere on the ground usually, and it is fixed to the map of markers that we have set up. And there is also a map frame of reference. Those are the coordinates that are the default for the entire drone, and they do not require Aruka map to be there. Well, when you power on the drone, it will put itself in 0, 0, 0 in a map, and whenever you move it, even without any external sources of navigation, it will detect its movement and change its own coordinates to map. Well, for you, if you are new in with drones and robotics, it might be a little bit hard to grasp from the first time, but I hope you will go deep into it later and after we go into practice part. If you have questions, you can ask me. And this is the Aruka map system. So here is 0 coordinate. X is going to right, Y is going to forward, and Z is going to up. Well, actually, to be fair, X is actually going forward and Y is going left. But it's easier for us to understand them as right and forward. Well, you will notice the difference later when you start programming a drone. If you have a body frame ID, well, X is always forward, Y is always left, and Z is always up. And to program the drone, you need to import the Clover module for Python and ROSPy module and some other things. I will show you how to do that later. So now let's set up our simulator in order for it to be able to work with Aruko markers. All right, let's see. You need to configure the file called Clover Launch and also Aruko Launch. And you need to create your own markers map. Then you will check everything up, and if it is working, then you're ready. Okay, let's do that. So let's open this file, Katkin ABS, src Clover Launch, Clover Launch. So this is the file name, and this is the path before this file. This tilde sign means that this is in home folder. So it is basically stands for /home/username. Let me show you. So here, Katkin WS src Clover Launch, and we have all the files needed. So Aruko Launch, Clover Launch. Let's run Clover Launch in Visual Studio Code and find the line that we need to change. We need to find arg name Aruko default, and there for now there is false, but I will change it to true. Let's find it. Arg name Aruko default false. Close this if it opens up. So Aruko, replace it with true. I also want to enable blocks programming, and this is then line 13, and set it to true as well. Control S, and you can close this file. All right, we have edited this file. Also, we need to edit what we need to edit. Aruko.launch. Let's see what we need to do. Here in Aruko Launch, we need to edit Aruko detect, Aruko map, Aruko VPE, and possibly map.txt. We can replace it with another map name, which we will do actually. So let's do that. Find those three parameters and then find this parameter. All right, they are here on top. These three lines starting from 2 ending with 4. But let me show you how to edit this file in console, in terminal. I want to go to cd Katkin. Then I will start typing the next folder, s tab, c tab, c tab, /l tab, enter. And now I'm in the folder in this launch folder. Let's see. Yes, Aruko Launch, Clover Launch, all the same files. And then let me open this Aruko.launch with nano aru tab, enter. And as you can see, this is just the same file, but in another user interface. Well, you cannot move your cursor with your mouse. You can only use your arrows on your keyboard. So let's replace this false with true. And here. And let's find the line where our Aruko map is defined. So there is a map.txt file. It will reference to this file. It really exists on the file system, but we will create another file and we will name that another name. Like, let me name it test map. It's not yet in the file system. I will generate it in the next step. So here, test map.txt, and I'm ready to save this file. Control S, Control X. Control S to save, Control X to exit. Let's see, how can we generate our own map? So here is the command in terminal that we need to run to generate our map. And this here it's already populated with values that you need to type, but these are not the values for my field, for my map. I will replace them with others. So what are these values? First is the size of a marker, which is how many meters from this point to this point. If this is less than a meter, of course, this is a fraction of a meter. For example, if it's 28 centimeters long, then you will type 0.28, of course. The next number is dist x, then dist y, which is the distance between middle of one marker with the middle of another marker, the same as distance from the left corner from the one marker and the left corner of the other marker along x-axis, which is horizontal in this case. And dist y is this distance from the upper marker to the lower marker, the neighbor markers. Then we have, it's the second and the third parameter were x and y, which is not dist, but they are the number of columns and the number of rows. Let's see how many columns and rows we have. So x is how many columns we have: 1, 2, 3, 4, 5. And the y is how many rows: 1, 2, 3, 4, 5, 6. So it's 5 and 6. And then we will type dist x and dist y, which is, in our case, dist x is 0.7, which is 70 centimeters, and 0.5, which is 50 centimeters. All right. And then we have first, this is the number of the first marker, which is, if you see there is a digit, a number here, 0. So it starts with 0, then 1 and 2 and 3 and 4 and so on, and ends with 29. So our comment will look like, let me show you how. You can copy it from your host operating system and paste in your virtual machine with Control-Shift-V here. And let me replace 0.33 with 0.28. Then we have 5 on X and 6 on Y. So 5 columns and 6 rows. Then we have 0.7 dist X and 0.5 dist Y, and we have 0 as our first marker number. Then we will put this into a file, catkin.ws/C Clover argopose map test map.txt. This is the default value that I found in the article, and I will run it. It will create a file. And after I've done that, I can just run Gazebo px4, and it will load up all the things that I've done. After it runs, I can check everything up. Oh, look at this. We have a different map. This is not what we have on our real test site, and it is not what we have here in the Clover settings. So it was the default map that is shipped with our simulator. And if I open Firefox, I will show you what map is drawn trying to find. So if you go to localhost, /enter and open image topics here, then map image snapshot, you can see that this image is not the same as this image, because here you can see much more markers than here, which means that we need to replace our world with the world that we have. So how do you load the world? We will send you the file. It's a part of your homework. Well, it will be an archive. And here in my desktop, I have this folder world0, which contains some files. Models, Aruka Launch, Clover Launch, Kvan, Simulator Launch, World3.world. So I will put all these files into folders where they should be. And let me open it. Are you here yet? Isn't it too much information for you? Maybe you're tired or not. You can write me something in chat and I will give you the answer on something like that. All fine, great, Philip. Thank you. Yeah, great. So, yeah, thank you. So you're still here, which is good. I've just closed the simulator. How did I do that? I just opened the terminal that was when I launched the Gazebo, it opens a terminal. So in this terminal, I press Control-C, and it will stop the simulator. Okay. And now let me put my folder with this world onto my simulator. All right. And here you can see this world0 folder. So what it does, what it has all the settings already set in this launch files, as well as this txt file and the world file. So if you have this folder, you don't even have to manually edit Aruka Launch or Clover Launch, or even generate the Aruka map. So you can just install the simulator without anything else. Just get this folder and put all the files to the folders where they should be, and it will load up the world that we need to load. So what to do first? I will open this launch folder, which contains Aruka Launch and Clover Launch, and I will grab these two files from my world0 folder and drag them here and replace all. All right, two files done. Then I need to put this kvan.txt. It is actually a map that is generated previously, just the same as I generated and named it test map. So if you open it up and see what it contains, just numbers and some numbers and some numbers and so on. So macros number 0 has the size of 28 centimeters and some other parameters, which is the coordinate and rotation. All right, so this file should be in another folder, not in this one. You need to go back and open Aruka pose and map. So the whole path is home, Clover, Katkin WS, SRC, Clover, Aruka pose, map. And here I will put my kvan.txt. There was no this file before, so it doesn't ask me to replace anything. Then we need to go to the simulator to put and simulator launch and Clover world and the world3 world. I will go from the home. So home, Katkin WS, SRC, Clover, Clover simulation, resources, worlds, and here I'll put my world3.world. All right. Then go back twice, 1, 2, and open launch. And here the simulator.launch. All right. And replace. Go back once and open. Well, you can just drag models here and it will put the file from inside the models here to here. So it was arukvan.txt. It just appeared here now. And now I'm ready to open Gazebo again. Now let's check. We have our map image here, which is just the same as we have here. It's a good sign. We can try to take off and try to fly. There actually are some test programs that come with Clover. For example, if you go to Clover here and examples, there are 4 test programs that you can try. So if you go there and right-click Open Terminal here, you can run the program, for example, flat marker.py. I'll type Python flat tab, and then I need to provide some hint for the links to how to complete my file name, because there are 2 files starting with flat.py and flight_marker.py. So here I need to type _ tab and enter. Let's see what it does. It takes off, flies somewhere, another place, and lands. Wow, it is working. So let me close this terminal. So this terminal opens up with the simulator, so don't touch it if you do not want to stop anything. Some errors might occur here, so it is also a useful one. Well, our program is working and we can start to write our own programs. But what I also recommend you to do is, I think in this world, there was no, oh yeah, there was block programming enabled. So I can just open block programming here and yeah, it's not enabled. So I need to enable Clover blocks in Clover Launch in order for me to program in blocks. All right. Let's open this file and edit one line. Well, the easiest way is to go to CD, enter CD, Katkin SRC Clover Launch, Nano Clover Launch, and find blocks, change it to true, Control S, Control X. And now we need to restart the simulator. So here in this terminal, I will press Control C. Control C will not copy anything in this case. In this case, it will cancel or stop the program. All right. So for those of you who do not know how to program in Python, blocks is a great way to start. It's just a great way. So run Gazebo again. Wait, let's wait. Sometimes it will not load, but let's wait like 30 seconds. And if it doesn't load, we can just open it again because we don't want to waste our time. Yeah, I think I think we need to restart the simulator. Here in terminal, I'll press Ctrl+C and open again. We can close the folders that we do not need. All right, let's try again. Yeah, now it's working. All right, let's open now blocks programming. Yeah, there's no error. And here in flight, we can select blocks for taking off, for navigating, and so on. Taking off, it will take off to the height, to this altitude, like 1 meter. Then we can select navigate to point, put it, and connect them. And here is the frame ID. Well, you can select body or markers map or just marker or last navigate target or map. Well, you can read about them in the article. Let me show you where. So here there is a coordinate systems article, frames, the list of available frames and a few words about them. But you should experiment with them to learn more. So I want to take off to 1 meter. Then I need to fly, for example, to the point. Wait. Oh, if you see this, it means you need to restart the simulator. So let's do that again. For now, I will write the program. Well, you need to write. You can write actually without the simulator working. Then you can just run it. So here, I will select markers map. And here, X, Y, and Z coordinate appeared. Before, I had only body. When I had body, there is forward, left, and up axis. When I switch to markers map, it changes to X, Y, and Z. And here, let's select 1 meter, 1 meter, and 1 meter. I'm running Gazebo again. And here, maybe it's better to select 1 meter and 2 meter on X. So okay, let me 1X and 2Y. And here we can, let's see if it is. Yeah, I think we should restart the whole virtual machine because it started to behave inadequately. Sorry for that, but it happens sometimes. You need to get ready because it's kind of a new development and some bugs may appear. If you face a bug, please let us know and we will fix the bug in future versions. So to restart the whole virtual machine, just close it here and select power off. After it powers off, you should run VMware Workstation again. Select the virtual machine that you want to run and play. Okay, let's run Gazebo and Firefox. So here in Firefox, I still have my program, which is great. I don't need to rewrite it. And I want to go to this point, then land. So land wait is the block that we need. Okay, let's try it. Run and okay. Now the drone is taking off. Let's see. Yeah, it's taking off. It's going to the coordinate 1x, 2y, which is just here, and lands. Great, it is working. A cool thing about blocks programming is that it will generate Python code for you. So you can click Python on the right here. I mean, on the left, the second block. And this is the Python program that will do the same thing. It is a little bit, what do you call that? Well, a human would write it a little bit differently, but it still is working, and you can write over this program. So you can just take it as a reference and continue writing what you want. So what it basically does is it's calling the navigate wait function, which is a Python function that will call a navigate service, a ROS service. Now I will need to say a few words about ROS and about where you can read more about ROS. Okay, so those are a few services that you can call, and there's a link. Let me open this link here. So it's called Simple of Port. This module this module is written by COEX, and we developed it like since I think it's since 2016 or 17. This is a Python module that will give you some services. So what is ROS? ROS is a framework. It's usually installed on some Linux-based operating system, and we have a Linux-based operating system on our Clover drone as well as on our simulator. And ROS allows you to build a software for robots. It will connect different programs into one system and allow them to exchange messages and to call each other's functions and interact with multiple robots at the same time. And it is all available in Clover. So nodes are basically the programs that are running. And the nodes, each program in ROS is a node. So this program is also a node. If you read it, you can find that it has import ROSPy, and then it calls ROSPy init node function that will initialize the node name. And the flight is actually the name of this node in the ROS system. It's you can change it with everything you want, but make sure there is no two nodes with the same name running at the same time. The name should be unique. And get telemetry is a service proxy. So let me show you this article and talk about services then. Well, a service can be assimilated as to the function that can be called from one node and processed in another one. So for example, there is a node that has functions that will make the drone fly to a certain direction, or that will make the LED strip light with certain color. And you can access Yeah, and you can access these nodes, these functionalities from any other program that is connected to ROS via ROSPy module, or maybe ROS for C++, and depending on the language you're working with. So yeah. And this is the services. And there's also topics, which is the way of exchanging messages. So basically topics, you can think of them as like group chats or Telegram channels or news channels that any node can subscribe or post messages to of the messages of a certain type. And in Clover, you also have topics, and some of the topics are image topics, and you can go to localhost / open view image topics, and you can see all the image topics available. For example, Aruko map debug, a great topic. For now, it is only showing you a picture of ground, but if you take off, you will see what it does. So let me take off real quick. If I write a program that will take off, wait a second, refresh, yeah, I will take off and go to the 0, 0, and 1. Run, okay, and switch to debug here. Let's see, yeah, as you can see, it now shows me the coordinates of the Aruka map. And this is an image topic. Any program can subscribe to the topic and get images from it. But there are more topics. If you open a terminal, another one, not this one. Let me increase the font size. And type ROS topic list, enter. It will give you the list of all the topics available for you. For example, there is a great topic, rangefinder range. If you type now ROS topic echo / range tab, enter, and it gives you the real-time data from your rangefinder, which is the distance between the drone and the nearest object under the drone. And if you take off again, you will see the data change. The range value will change now, and yeah, it's increasing, and it is almost 1 meter now. It's 1 meter, and it's decreasing, meaning that it is landing. Okay. Control C. Arrows. Yeah. So topics is also, you can post messages in topic, or you can read messages from topics. This is a great way for different programs in your robot to exchange messages. Basically, usually there is a one node that is always posting to certain topic, and many other nodes subscribe to this topic and use this information for their function. It can be coordinates and can be anything that can be measured. Yeah. Do you have any questions on topics and on ROS? If not, we can continue with writing our own Python script and testing it out. Okay, let's open now the article called Simple of Board. Here in this article, we have a Python example that you can copy and paste in your code editor. I will copy this code and open my code editor in the simulator. So it's best to create a dedicated folder for your code. So I will open Home, create a folder called Progs. All right, here I will store all my programs that I will write, and open VS Code from my desktop. You can close a file if it's opens here, and here File, Open Folder, and I will select the Home and Progs. Okay. So here now I have Progs on my left, and I can create a new file by clicking this icon. Let's call it 1.py. And I will Control V to get from my article. So this is basically you will write this in almost every of your program. So you need to import some modules. You need to initialize the node name. Here is flight. And then to get access to services, you need to create a proxy for them. So those are some, basically they are objects of a certain type. And let me increase the font for you, I think, like that. Yeah. So to work with services, we need to create proxies. If there are services that you are not going to use, you can remove them from here. For example, Navigate Global requires GPS to work, so I will remove it from here, but it's not necessary. You can just keep it there. And now for taking off, I can locate these get telemetry descriptions. So here's the parameters that you can provide, that you can pass, like to get telemetry or to navigate. I want to navigate, to use navigate. The parameters are X, Y, Z, your rate, and so on. So here are examples of how you can take off. So ascending to the altitude of 1.5 meters with the climb rate of 0.5 meters per second. If I just copy this from here and paste it here, save this program. All this program does, well, I mean, all this program will do is just take off, and that's it. The drone will still be hovering after the program ends. Let me run it. You can run the program right from here by clicking Run Python file in terminal. I pressed this button and the terminal appeared here, and let's see. The drone is taking off, and now it is on certain height. And the program stopped already, so it just worked and it stopped. Okay, and what if you want not only take off, but go to certain position? And here you can find a flying to point 32 with the altitude of 2 meters in Aruka map coordinate. Let's copy this part. And one important thing when you are working with Navigate, you need to provide some time for the Navigate to over. For example, if you are taking off, it will take you maybe 2 seconds or 3 seconds, depending on the speed, to complete. So I will need to type this manually, crosspy.sleep, and let it be 4 seconds. And then I can only type the next navigate. And for the drone to reach this point, it will take maybe 4 seconds. So I can copy here and paste it here, and then call land. Land is the easiest service. You just just write land and open closed parentheses. Control S to save. If you want to put the drone down, if you want to land it, you can open actually this terminal and type right in this terminal, Commander land. Let me increase the font size so you can see. So this is the terminal that opens up with Gazebo. You just type Commander land, and it is, wait a thing, I think there is an error. Commander land. All right, it is landing. The same as Commander takeoff. If you type Commander takeoff, it will take off. But I wanted to land, so I will type Commander land here. Commander land. All right. So, and I wanted to run my program, this one, that will take off and fly to a point, then land. Takes off, flying to a point, and lands. Great. And now you can add another point. Yeah, the folder. I will send you, once we have a break, I will send you the folder and the files that you need in Telegram. So just wait, we will have a break just in a few minutes. So you will have it soon. Okay, here I can add another point to fly to. I can just copy this, navigate and by sleep and paste. Yeah. And I will choose the coordinates of 0. Yeah, I changed X to 0 here. And let's try this program. Well, I will actually replace all the coordinates. So it will be 0 and 3, and then 3 and 2. Okay, I think it's better now. And save it and run. So I can run the program from any place. I mean, the drone can be in any place. It will still go to desired coordinates. Yeah, it's first coordinate and the second coordinate, and it lands. And just to demonstrate you, I can write a program here in blocks. So 0, 0, 1 and 2, 2, 1, and the markers map and land weight. So I just wrote this program in blocks, open the Python, copy the whole code, copy, and create another program. Control V and Control S and run. Let's see if it does the work. Yeah, it is working. Okay. So what we have next, now we will have a little break. So let me close the simulator for now with Control C. Let me see my program. Yeah, so Svetlana, I give you a few words before we break.
Hi, thank you, Timofey. So guys, so we have a break time for now, but before we start the break time, just a moment, I will remind you about our program. So after the break, we will continue our practice time and provide the mini game again. It will help us to fix your knowledge about the theoretical and practical material. So now we start the break time. Hi guys, 20 seconds still. So guys, are you here? Our break time was finished. So if you're here, please write message in the Zoom chat. Oh yeah, I see. Great, great. Nice to nice to see you in the Zoom chat. Nice to hear you. Okay, so I think we can ready to continue. And now will be a block of our working with the real drone. Timofey, are you ready?
Yes. Okay. Thank you, Svetlana. Today, and now will start to work with this real drone. We need to learn how to connect to this drone and how to program it, how to run programs, some safety rules, very important thing, and something more. All right, what we will begin with. First of all, this drone is already set up. So I've set up the arc marker map for it. I've enabled arc markers and changed all the settings. I did the same settings in virtual machines, so you can watch the video again and do the same with your drone. But there are more steps in a real drone that you need to follow, and I will show you briefly what you need to do on my screen. Let's see. All right, so when you get your drone, you need to follow all the assembly steps, then configuration steps. The most important are this: preparing the micro SD card and then flashing the flight controller. In the flight controller, follow the settings that are here. Well, you may keep PID the default ones because on some drones they work better, but it's better to experiment with it. So calibrate all the sensors, RC, and flight mode. So flight modes is very important thing. Make sure you have enabled all the flight modes necessary. So I will connect my drone's flight controller to the computer. So I will show you how you need to set your flight modes. This is the Q ground control program, and I will run. Let's wait for the Q ground control to run. Okay. So here we need to reconnect the drone so it detects in Q ground. Sometimes some of the USB inputs will not work. So you can either try to, where's my Q ground control? No, it doesn't. Oh yeah, now it detected. Okay, so now my drone is in ground control. You can see when I move the drone, I can see the movement here. All right, so in settings, go to flight modes and make sure you have set your remote controller. So on the SWC switch, there is a channel 6, and it will change between stabilized, and position. So there are only 3 positions available: first, the 4th, and the 6th. The position will use camera to stabilize, to hover on certain position using camera and arrow markers, and stabilize will not use that. And then you need to also set kill switch. In my case, it's SWA switch, which is the top left one, and now it is on channel 5. Very important feature. All right. Also, make sure you have correct voltage dividers so that you can see the current voltage of your drone. How to calculate it is very easy. You can read in the documentation. And be careful not to calibrate ESC when your propellers are installed, because it may cause unintended motors run. All right. What else? There is our firmware that we recommend you for downloading, and it's already installed here. And now I'm ready to test this drone. So for now, I will, we need to turn on our RC transmitter first before we turn on the drone. It's a safety rule. Another safety rule is to plug in your battery only in the safe flying zone. So I should not plug my battery in outside the flight zone. And one more thing is, there is a buzzer, which is a device that will show you the battery voltage, and it will buzz when the battery voltage drops below a certain amount. So you need to connect it properly, like that, and wait for the voltage. Now is showing up, and you need also to set the minimum voltage to buzz. So here, if you click, there is 3.3, which is quite low. I would suggest you using 3.4 or 3.5. So I will set it to 3.4 in this case. And now I'm ready to plug in the battery inside the flight zone. So I will go in the flight zone. Let me show you the camera view of flight zone. Okay.
Медленнее на камеру, я на 6 Подожди одну минуту.
And now I will put it on the jaw. Come closer. Yes, and our battery and the buzzer on the drone, and the controller is turned on, as you can see. I will put in the battery. So the front part of the drone is here, and the rear part is here where the wire is coming out. Let's wait for the drone to load. When it's loaded, it will light up the LED strip. We can wait, it takes about 20 or 30 seconds. Yeah, now LED strip is working, and we can test how the drone is working. So to arm the drone, we need to put our left stick to the bottom right position. So and to disarm, I put it to the left position. So arming is bottom right, disarming is bottom left. And there is also kill switch, which is this channel. If I arm the drone and hit kill switch, it will be off, but it's still armed. As you can see, if I put kill switch off, the propellers are still working. So be careful. If you kill switch, make sure you disarm the drone, and only then you release the kill switch, which is very important. It may save you fingers and something else. All right. Let's go to the computer now. Okay, I'm back here. Now I will connect my Wi-Fi to the Clover. And here in the list of networks, there is a Clover and some 4 numbers. They are random, and on every Clover they're different. So you can let's wait. And here it asks me for the security key. Sometimes it will ask you for a PIN code, which is not present here. So you cannot access it with PIN code. So you need to click connect with a security key. Let me try again. Maybe this time it will ask. Yeah, now it is asking me for PIN code. I will not enter anything here. I will connect using the security key. So click this. And the password is Clover Wi-Fi. Clover Wi-Fi. Let me show it to you. Clover Wi-Fi. Yeah, this is it. Remember? Clover Wi-Fi. Okay, next. Yes. Wait a little bit and yeah, it says there is no internet, but it's connected, which is what we want. There is no internet on Clover, but it is connected. Let's open our browser and go to the new tab and type here the IP address of the Clover, which is 192.168.11.1. And remember, I typed similar thing in the simulator, which was localhost /, but in this case, the same thing goes under IP address. So in real Clover, it's IP address, this one. And in the simulator, the same thing is under localhost. Okay. So now I'm on my IP address, and I can open image topics and see some camera image. Let's see. Yeah, it's the camera view. Some Aruka map image snapshot. Yeah, this is my Aruka map. And also, if I go back, I can open web terminal. So this is a butterfly web terminal. There is a password, which is another password, and the password is Raspberry. So if you type Raspberry, enter, it will not show when I type in, but the password was Raspberry. This one. Yeah, and the password from Wi-Fi was Clover Wi-Fi. So don't get confused. There are two different passwords. All right, ls will give us the list of programs and files and everything else in our file system. If I want to run some example programs, I can go cd x tab, enter. ls will give me the list of files. But let me show you first what are the settings in this Clover. So if I go cd Katkin src clover / launch nano clover .launch, and here you can see that I have Aruka true and blocks true. You need to do the same if it's not. Okay, Control X and nano Aruka launch, which has all this true, and the map called map.txt, but I have actually replaced the original map.txt with my map. And I generated it with the command that you can find if you go, for example, on the 192.168.11.1 and open documentation, you can find the documentation right from the Clover. So programming, fiducial markers Aruka, map-based navigation, and marker map definition. So you can copy this command and paste it to create your own map. Right. Go back to CD, enter, and let's go another window and open blocks programming. So here in blocks programming, I can write a program, take off, then navigate to point. Let's select Aruka maps, markers, and the coordinates 1, 1, 1. Then another, well, I can actually copy and paste and select here 2 and 2, 0. All right, let it be like that. 2, y, and 0, x. And then copy and paste again. And let's choose 0, 0. And land weight. So this program will fly from point to point and land. Okay, now I need to show you how to get ready to the flight for the flight. Before I run the program, I need to make sure my markers are recognized properly. So for that, I can open I will open the camera so you could see the Clover flying, and I will take off. Then I will switch to position flight mode, which will make the Clover hover on one point when I'm not moving sticks. So it will use vision-based navigation to maintain its position, but I will be able to control it anyway. All right, so first I will show you on camera how I will do that. So first I will arm the drone like that. Then I will take off to a certain height, make sure the drone is stable, and I will switch to the bottom, switch my SWC to the bottom position, which will put the drone to position flight mode. And then I will immediately put my throttle stick to the very middle very, very middle, make sure all the is just on 50%. If it's lower, it may cause some problems, or if it's higher, it may also cause some problems of stability. After it's in the center, I can then move it up and down to control the height of the drone. All right, now it is all the up, and I will arm the drone and take off, then switch to position flight mode and this to the center. Okay. Now I will demonstrate my screen with the camera. Yeah, it takes some time for it to maintain its height. Wait a few seconds. All right, now it's in the stable flight. I will move the drone so you can see how it maintains its position. As you could see, the drone was hovering on one position, and I tried to move it away, and it returned back to its normal position. All right, now, before I take off again, I will show you what to do in case of emergency when I need to take the controls. So sometimes there is a bug there may be a bug in the program or in a firmware or in software, and the drone moves where it shouldn't. For example, it goes straight to a person or into a wall or to the ceiling, and you need to take back the control with your RC controller. And to do that, you need to switch between modes. I will show you how to do that. So as you can see, this is my SWC switch. And before I take off, I usually put it down to the very bottom position. And then I run the program. It doesn't matter in which position it is before taking off. It will anyway switch to the off-board flight mode, which is the controlling from onboard computer. And then if something happens, I keep my throttle somewhere in the middle in order for the drone not to fall or not to fly up. It's somewhere in the middle. And I will switch SWC up, and now I'm controlling the drone. And the program is still running in background, but I'm controlling the drone. All right. And before I run this program, I just will put this left stick in the center and SWC in the bottom. Okay, let me just demonstrate the screen. And now I will run the program from Clover blocks. Okay, are you ready? Run, and here I need to hit OK. Yes, it is flying. And the second spot, and the third spot, and it's landing. Okay, the flight was fine. I didn't have to take control. Let's write a program for Clover. We can basically copy our program from simulator. We have this 2π or 1π. Let's see what's here in 1π. It's taking off, then 0332. I think I will edit this program a little bit, so I will replace 3 with 2 and 2 with 1 because our field is quite small, and also the height of 2 meters is too much. I will replace it with 1.5. Right. And takeoff speed, I like to use 1 meter per second instead of 0.5 and 3 seconds for taking off. All right, this program here, I can copy this program and so, hey, so what's happening? Yeah, I've copied the program and now I can open the web terminal. It's no longer the virtual machine. So here I can create a file, nano1.py, Control Shift V, then Control S and Control X. And now I can type Python 1.py, prepare my remote controller. So SWC in the bottom and left stick in the middle. Let me also open the camera. Yeah, so again, this in bottom, this in middle. So again, the left stick in the middle and SWC in the bottom. I always ready to heat it up and control the drone. And now let's run the program. Where is this? Okay, ready? 3, 2, 1, run. Great. Now we can, I think, Svetlana, are we ready to proceed to our mini game?
Okay, guys. So, okay, guys. So, what do you think about this topic? So it's really unusual when it works in your simulator and then it works on the real drone. Okay, so I would like to demonstrate you our progress for today. So just a moment, I'm going to share my screen. Yeah. Just a moment. Yeah. So we have finished our first game. So we have finished our coffee break time. Now we have finished working with the real drone. And now time for the mini game. Elena has prepared for you special questions. Be ready. Elena, are you ready? Welcome.
Thank you.
Good luck, guys.
Guys, are you ready? Okay, guys, let's start. And first question for you. What service should you call to fly to the decided point in the straight line? Okay, next question. Second question, what is cross by sleep? Okay, yes, is right answer. Waiting for some seconds. Next question. How do you stop the simulator? Control Z, Control C, Control V. That cost it. Yes, Control C. Next question. What does the sudo command mean? Yes, you're right. And next question, what is the password for the butterfly terminal? Okay. Results and next question. What is Clover's IP address?
Guys, we have check your memory.
Great.
We have changed the leader. Now, leader Mikhail is the second place.
How do you switch the copter to disarm state?
Let's check your arming skill.
Almost, yes. Be careful and read question. At what voltage is a 3S battery time to land the copter if the minimum recommended voltage for the band is 1/2 and 3 volt? Sure. Next question.
Mikhail the first again. Vitaly on the second place.
Which motors rotate clockwise? It was difficult for you? Yes. And finally question. what's the password connecting to Clover via Wi-Fi? Are you ready to get a result? Our podium. Third place, Darshan, congratulate. Second place, Vitaly Fan. And first place, Vagon Mikhail. Congratulate.
Thank you guys for participating in the game. Okay, guys. So now we have changed the leader of the previous Kahoot. So guys, I advise you to be faster. But during this Kahoot has an interesting question, really. So, and also it will help you to assemble and run the drone correctly. Okay, so we are ready to continue. We have a little time, but we have only one topic. It will help you to do the homework. And then when Timofey is finished, we will give you a homework task. Okay, Timofey, please continue.
Thank you, Svetlana. All right, now I will show you how to create your own world in Gazebo. It is important to know how to do that. I will show you a quick way. There is also some more sophisticated way, but this is not what I'm going to show you today. First, let me demonstrate. Let me share the screen with you. Where is it? Okay. Can you see my screen? I hope so. So what is actually a world? What the world in Gazebo is? If you open the file system in Home, Katkin WS SRC, Clover simulation, resources, worlds, there are a few worlds that are available for you. And we are currently using the world 3.world. If I open this up, I will see this file, let me see. It looks like an XML document, so it is actually XML, but it is only white text, which is not very convenient. You can select here on the top, on the bottom right, instead of plain text, click here and type XML, and now it highlights the syntax. So this is a description of what you have in your world. Most important here is include, then URI to model, and then position of this model. And then /include will indicate that this inclusion is over here. Then the next one opens here, closes here, which is model sun, then model parquet plane. And the position of the parquet plane is a little bit below than 0. And some other parameters, we do not need them. And this is basically how you can edit and add your objects in world, but we will do it a different way. It is easier for you, but will not look as it will not look as clear as it looks here. We will do it right from the Gazebo user interface. First, let me open the Gazebo, and I will show you how to create simple models there and how to access them later. Okay, when you are editing models, I recommend you to, well, when you are editing models and editing worlds, I I advise you to delete Clover from the scene, because if it's there, it may cause some problems. So I select Clover and hit delete, and it's gone. Also, you can pause the simulation. So here is pause. Now it consumes less CPU, and you can play around with objects. So here are some box model, like ball and a cylinder, like sphere, box, and cylinder. You can edit these models and make your own models based on them. For example, if I want to create a small marker with, well, a small colored marker, I can select this box, hit right click and edit model. Then I select it again and right click again, open link inspector. And here in visual, I can maximize this visual menu and change the geometry of the object. For example, if I want to make a small 0.5 by 0.5 by 0.02 meters object, I just hit here in geometry. Then I go to collision. I need to edit collision the same way. He changed the geometry the same way. So collision is actually a physical model of this object, whereas visual is only visual model, so it will not interact with other objects unless they're the same size. Okay, now it's the same size, and you can see it's much smaller than it was before. Here in visual, you can go back there and scroll down to change the color. You can edit. There are a few parts of a color, which is ambient, diffuse, specular, and emissive. The most significant are ambient and diffuse. So if you change like ambient to 1 in green, 0 in red, 0 in blue, and also you need to change diffuse to higher values in green, and maybe not 0, but close to 0 in other parameters. The A means alpha, which is how transparent it is. 1 means it's not transparent. 0 is transparent. Specular is shininess, I think. Yeah, emissive will, well, it will be like it's a lamp, but it's not working in Gazebo, so it will not change anything. So you can hit OK here. It doesn't look very green, but it's because in this editor, colors are a little bit changed. Hit OK, and in the model menu, hit static. So this model will not be, it will not interact with gravity. It will just stay on the place, and you cannot move it somehow with physical impact, which is what I want. Then you can save this model by hitting File, Save As, and let's call it green. This is the default location. We can move it from this location later. Hit Save, then File, Exit Model Editor, Exit. As you can see, the green object here appeared. It's floating in the air, and you can insert it from this menu and put it wherever you want. And now, if you want to change, if you want to create another color, you don't need to create a box again. You can just hit it, right-click, and edit my model. Then hit again, right-click, visual, scroll down to change the color. And if I want to make it blue, I will replace the values. Okay. File, Save As. Instead of green, I call it blue. Save, and File, Exit Model Editor, Exit. And now I have another model, which is blue. Okay, now we've added some models, but I recommend you now to remove them from their current location and put them into models folder. So to do that, I will close Gazebo for now, Control C, and open Home. In Home, there is another folder, Model Editor Models. It just appeared, and two folders in it, blue and green, which each one represents each model. If you select them, and on the other window, I have, if I go back, I have this Home Clover, Katkin WSSRC Clover, Clover Simulator folder open, and models. So I'll put them in there. It's better to store all the models there. All right. And now we can, we have created them. We can also add some other models that I have created before. So this is the folder where I have all the colors, not all of them, but some: blue, cyan, green, magenta, red, and yellow, as well as Haruka map, which is already there, so I don't need to copy it. And I will put these models in my folder. How to do that? I can just drag onto desktop, and let me drag them back into this models folder. Replace if it asks to, because I do already have a green and blue. And there is also a cool pack of Haruka markers, which is, it has 100 markers, starting from the number 200, ending with 299. I will put this folder also in my simulator. Wait, like that. And I will put them here. Well, not all of them. I will just select a few of them because I don't want to have so many models available. It's not convenient. All right, now I can open Gazebo. I will give you the spec so you can use it, and you can change textures in there. Yeah, there is a question. Can we import multiple drones in the world for making drone swarm? Well, it's not going to be that easy, but yeah, it is possible. I personally haven't done that, but my colleague did, and but there are some limitations. For example, you cannot use visual-based navigation in all of them because it requires too much resources. So maybe only GPS. All right. And here in insert, I have models, which are here: blue, cyan, green, magenta, red. Yes. And also some markers, Haruka marker 200 and 201, and so on. And now, if you want to save this world, you need to delete Clover, put your models where you want them to be, for example, like that. Yes, and what else? And you can save this world just by hitting File, Save World As. You can save it in Katkin SRC Clover Simulation, Resources, Worlds, and name it maybe World 4. .world, save. Okay, and to enable it, you need to do the following thing. Here, I go back. As you can see, there is World 4, but it will not load by default. By default, there is World 3. To enable it, you go back 1, 2, open Launch, and open simulator.launch. Here in this file, there is a line 17, which references the world. So here, instead of World 3, I will write World 4, Control S, and run Gazebo. And now it will load. Yes, it is loaded. If you want to send this world to someone else, you should, what you should do is, you should not only send the world file, but also it's better to send all the necessary files associated with this world. For example, all the models and all the launch files and also the map txt file. So I will just do a real quick export for you. So create folder world4, all right? Here in resources, I will copy the world4 and paste it there. All right, go back, copy the whole models folder and put it there. Open launch simulator launch, put it there. All right, then I go to Clover, Catkin, WSSRC, Clover launch, copy Aruka and Clover launch, put it there. Go back, open Aruka pose map and Quant txt, which we reference in our Aruka launch. So it needs also to be exported. And that's it. You can now send this folder. You can zip it and send it to anyone you want. And then someone will put this folder in their simulator and you have exchanged this world. Okay, and I've already showed you how to load the world this way, so you know that. It was in the first part when I loaded the default world. So there you go. You can create world, you can edit it, you can send it to someone else, load and so on. Well, it was very quick. Svetlana, are we ready to go next?
Yes, of course. So guys, are you alive? This was a really hard day. It was really hard work. So how do you feel? Have you tired? You can write something in the Zoom chat and I see about your condition now and mood. Okay, great. So nice to hear that it was a wonderful day, really amazing. Thank you. So we have some information for you, but this little information, it's really important too. So we will tell you about homework, but before homework, please give us feedback about this day. We have prepared for you a short method when you give us feedback. So Lena tell you about how it works. Lena, welcome.
Okay. Yes, it's time to take stock of the day. And now you should go to menti.com and enter the code on the slide, on the screen.
It's a really it's really similar to Kahoot, but we use another service for it. Please connect on this service and write in the Zoom. Please write plus in the Zoom chat. While you connect to the Mentimeter, or we have one first answer. So yes, it's really great to see your opinion about this session. And also we hope that you will use the recording of the first day and will be prepared to the next days. Yeah, and also we know that we know a little information about level of you our attendees. So also we have a two level level advanced, but this level has a small number of attenders, and level beginners. It is more than half of our attenders. That is why we have prepared our program to involve and beginners and advanced too. So this information will be actual for beginners and for advanced level 2.
I'm surprised. It wasn't difficult for you. Okay, and second slide.
So by the way, we are waiting a great results in your home task.
Yeah, it's really great. We expected your best result in the home task.
And second question for you. What was the most difficult for you? I know that it was normal or easy, but
you should to write your minds and your opinion shortly, and your opinion will be shown on the screen.
Early time, I feel the same, bro.
Yeah, but it's really interesting because the camp has many participants from all over the world, and the earliest time it was for participants from United States. They start in the midnight.
okay, thank you guys. And we are finished for that.
Yeah, guys, thank you for your opinion. We will provide this feedback each day. And now I would like to check your attention. So what the topic we didn't to give you. So what topic we forgot to tell you before we finish our training? You can write in the Zoom chat. Not new safety, homework. Yeah, great, Darshan. Yes, we forgot about homework, but it's not true. So let's welcome Nikita Bogatov. He prepared the home task for you. Nikita, please tell us about this homework.
Yeah, thank you very much, Svetlana. Once again, good day, evening, morning, afternoon to all of you. Really nice to see so many people from so many countries. And some words about our home task. So do you see my slides properly or not? Could you please tell me? Svetlana, can you see my slides properly, or I have to make it full screen?
Yes, visible.
Yes, we see, but I think it will be better if you make a full screen.
Okay, so now it goes better, yeah? So your home tasks for the first day, we have divided it into 4 base points, and let's get attended with them. So your first point is to download and install the Gazebo simulator. Timofey has already told you where to find it, and we have placed the two main sites where you can get this. So please install the VMware virtual machine. After that, check that your Gazebo simulator runs well. Try to run it into your virtual machine and check if you have the airfield of the Aruka markers. So after this, try to run the demo version of code. It can be, for example, the code to take off and to land. Timothy also has shown you how to do it today. So you have to do it also to check if you have connection between your terminal in your virtual machine with your Gazebo simulator. So that will be your second point. And the third point is to install the ready built world in your simulator. So as you have already seen, when you run Gazebo simulator in your virtual machine for the first time, you will get the normal base Aruka marker field. And we have a little bit different field that you have already been given in our chat in Telegram. So please download the zip file, unzip it, and install into your Gazebo simulator. And after that, run it again, restart, run, and check if you have your new airfield. And the last point is the most interesting one, because that will be your first steps in the programming for someone not the first steps, but to repeat something is not very bad at all. So your task will be really simple. You have to take off from the first point. You can see it is here. Yes, it is placed here in the middle. Then you have to move to 3 meters or 3 Aruka markers to the up to the second point, then to the third point, then to the first point, and your last point will be the first point. So you take off and you land from the first point. It is the point of start, and that is the point of the end of your task. So you do it in Gazebo simulator. Am I right, Svetlana?
Yes, of course, you can do this homework in the Gazebo simulator, but also if you have a real drone on your site, you can perform this task on a real drone. It will be better, of course, for you. And also, guys, your solution, we expect to get in the video, such as a video of performing your homework, part 4 on this slide. So please send us video in the common group, in the Telegram group. And tomorrow we will check your homework together.
Yeah, yes, and thank you very much, Svetlana. And some points also to notice, please, your altitude has to be not higher than 2 meters. We think that 2 meters is the great altitude for you. So please check that you have this altitude in your code. And the size should be 3 by 3 meters in any place of your Aruka markers field. Of course, in your new Aruka markers field, not on base 1. And I will also create a PDF file of this presentation, and we will also send it to your chat in Telegram. So you will get this information once again in a document. So for me, that is everything about our first task. It is a bit easy, but it trains great skills, great first skills for you. So if you have any questions for me about the task, so please ask me now in our chat in Zoom, and I will sure that I will answer them.
Oh, also you can unmute your microphone and ask by voice. It will be good too.
Yeah, the best thing is to ask by voice.
Yeah, I think I suggest that many questions will be on the homework number 2, and the most number of the questions will be in the task number 3. Yeah, guys, we have prepared difficult task, especially for you.
So as I see, no questions yet, yeah?
Yeah, no questions, but also you can ask us in Telegram. Okay, no problem. So okay, so now I think we can finish, but I would like to remind you about our schedule for tomorrow. So let me share my screen. Yeah, so this is our schedule, and tomorrow will be the second day, and tomorrow you will learn how to provide color recognition using computer vision technologies on Clover drone. So Timofey will demonstrate you how it works in the simulator and how it works on the real drone. So that is why today we really advise you to install your simulator, to repeat all steps that Timofey demonstrated for you today. And this skill will help you to follow and understand all materials about color recognition and how to test it. Yes, and don't forget about homework, of course. Okay, so I think we can finish, and please turn on your cameras and we say goodbye together, and you will be prepared for tomorrow. Oh, hi Fatima. Hi Ismail. Great, hi. Nice to see you. Hi. Oh, hi Rakesh. Great, guys. We would like to see your tired faces of this day. But it is really great that I see your smile, your smiles. Okay, so thank you all. And maybe someone wants to say something, maybe from our team, maybe you want to ask us about something. If no, we will finish soon. Oh, hi Deepak, hi Philip.
So, firstly, I would like to say thank you for everyone from this team. It was very interesting and useful day. We done some exercises, get some new materials for some who have programmed Clovers before that course have got very nice revision. So for me, new was the block programming because I never had used it. And of course, the working with Gazebo was very interesting too. Thank you very much.
Oh, thank you, Mikhail. It's really great to get your feedback. So also, if anyone wants to share their feedback, it will be great too, because it will be really useful for us to understand what's the most interesting for you, what is most useful for you, and prepare our materials to have a maximum effective for you.
Yeah, I just say too that thank you very much for this opportunity to take part of this skill camp. Very useful, and good luck with homework for everyone. And thank you very much, the team who now in Sakhalin, yeah?
Yeah, we are on Sakhalin.
Not only in Sakhalin.
No, we have a spread team. Part of our team on Sakhalin, other part on St. Petersburg and Moscow.
Yeah, great. Thank you very much for everyone.
Okay. Thank you, everyone. So now I think the time is finished. Yeah. So you can unmute your microphones and say goodbye.
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 Bye. Пока-пока in Russian.
Goodbye, everyone.
See you tomorrow.
See you tomorrow. See you tomorrow, guys.